Everybody give it up for Brooklyn.
All right. Hi, everyone. As mentioned, I'm Brooklyn Zelenka, and we're going to be talking about exceptional today. So obviously that's my name, and where you can find me basically everywhere online is as xp'd. Did found Robot Overlord, still exists, still around, I'm still involved, but these days I've been sucked into that whole blockchain thing, like a large number of functional programmers have been. So I'm now the chief scientist at the Special Projects and Decentralized Engineering Company. We're going through a tech accelerator and an open source grant currently in San Francisco through Consensus. I've written a bunch of standards over there, and I'm a programming language and correctness nerd. I've written a bunch of Elixir libraries. The ones that I'm best known for are the Witchcraft Suite, which are the ones I've mostly been giving talks on. So it's somewhat refreshing to be able to talk about something other than the Haskell-like libraries. Exceptional, which we're talking about today, is really nice, focused error handling library. And community stuff. I run a couple meetups in Vancouver, including a conference earlier this year, Confin Coffee, and founded the functional programming meetup out there. If you ever happen to be in Vancouver, drop us a line and come say hi. So let's all get ready for some error handling. Woo! Error handling obviously is a necessary evil. Breaks down into two broad categories. We have exceptions, which are recoverable. You know that these are the kinds of things that can happen ahead of time. You can find a way to get out of the situation without causing a big problem to your state. Doing something that's going to cause you more trouble down the line, right? Something went wrong, but it didn't. It's not the end of the world. The other aptly named errors are your unknown unknowns, things that you should not continue with. These are dangerous. You should halt. If you're in a transaction, get out of the transaction. And it would be really nice if we had one way to handle both of these cases the same way and make a choice about which one we're in without making this decision up front. Luckily, there's one little magic line you can use, and that's use exceptional, and then it gets you a bunch of operators and other functions. So let's talk about the current state of the art. Tagged statuses, or tagged tuples. These are the bread and butter of Erlang since, 1986? Right? You've probably seen one of these before, hopefully. They're great because they're very, very lightweight. You can pass them around. You can do just hundreds of thousands of these things without breaking a sweat. And this is the classic Erlang style. Roughly, they break down into a atom, which is your status or your tag, and then some data that the tag is describing. Obviously, you can have more tags than just these two, but these are the two that we're going to be talking about today and the ones that people use for error handling. They're great, and it's definitely a style. Go has adopted something very similar. It's starting to propagate as a general pattern. But there's a couple issues with it. One is that your tag can get out of sync with your data. We don't have a data constructor. We have no way of, when we're making one of these, because we're just leveraging just a regular, normal data structure, we can end up with a tag that doesn't describe the data, right? So in this case, we have a OK, that's actually a horrible error state, and you can end up in the opposite situation where you've tagged error for something that you actually want. And then the other one, and this is what the very kernel beginning of this library, is when you have multiple arities, and you need to pull out, say, the second value from here, and now you have to pattern match on several. And yeah, sure, you can use elem to grab the second one. Probably not great practice, because if you need the fifth one, you don't always have one, right, if you have a large number of these. This really came from, we were using an old XML parsing Erlang library, and with a bunch of undocumented tuples that can possibly come back as error states, and we were getting all kinds of fun and interesting runtime errors because we weren't matching on the right stuff. Pieces of data were in the wrong order, et cetera. So the positionality really hurt us in some cases. You work with these things with. So a quick recap, you've probably seen this, it's becoming more and more popular all the time. You do something on the right and pattern match on the left. If the thing doesn't pattern match, you fall down into the else case. With the pattern match, you can then go into the next one and thread through your state, and then in this do block, do your the main work that you're going to be doing. This is a pattern known as railroading. So we have some input, and then this else case. And we do a function call, we get back some new value, and there's two possibilities here. We either get the thing that we actually want to pattern match, this lower box, or we fall through into the else. And then we can continue threading through with the same pattern, and then at the end, we actually need to make a decision about which one of these we're in, unless the else case gives you some nice default that looks similar to what you would have had in the final value in the happy path. So as I mentioned before, this is like threading a needle through the fabric of your code repeatedly. By convention, this is about pattern matching. It doesn't have to be, but people tend to do this with tuples and then pull values out. You could just have an entire value, but that's not really what it's for by convention. And everybody who learns about Elixir really loves pipes, right? When I teach, we've done a bunch of corporate training on Elixir getting people up and running, and pipes just blow everybody's mind, right? You don't have to really think about it. You just pipe through, and you have this really nice just flow in your data. Doing this threading is much clunkier than having the ability to pipe through things. And you end up with a lot of intermediate states because you have all of those parts on the left-hand side. And then, yes, as I mentioned before, you can miss stuff in the else case, especially if it's under-documented, or if it's documented, but there's, say, 16 cases, and say, only really ever get these 3, or I only care about something that's too long, and then it's actually, 6. So the position dependence hurts, and then having to match these separately is kind of annoying. Makes me feel like this. The other way of doing error handling is with raise, which you've also probably seen, and it feels a lot more like other languages, right? Like Ruby, Java, et cetera. I've heard some people call this the object-oriented way of doing error handling, but you see this really everywhere. It's not specific to even the imperative style. Even, say, Haskell has something like this. It's totally pure language, but there will be some things that happen that don't even make sense to try to catch in a pure way. So you can raise just a regular string and get back a generic runtime error. You can raise a exception struct, which we'll talk a little bit more about later, and get something that has a little bit more context to it. So this is a out-of-bound error. So if you try to, say, get the 100th element of a 3-element list, you'll get one of these. And then you can rescue from arrays, pretty much a safety net, and then pattern match on that, and then even have some cleanup afterwards for either case, the happy or the sad path. I like to think of this as an uncontrolled detonation. You don't get any aggregation and any context other than this thing exploded. If you're reusing this function that raises, you now need to either let it just blow up completely or do error handling in every specific, wrap a try block around every single call site that you have it in, or wrap your entire application in one and then handle all of the cases right there. Because you don't have a controlled unwind of the stack, you lose a lot of information or context. As you have your first function call and then it calls out into sub-functions for handling your sub-problems, every step along that stack has more information than the thing is calling out to, right? So when you call, say, enum.map, the thing doing the enum.map has a lot more context about why you want that than the function that's handling updating every element in your list. And this encourages people to use the unsafe bang functions, specifically so that they don't have to worry about doing the threading and pattern matching with a tagged tuple. I see this, walking into a code base. I see this a lot, where people will have file.read bang, and if the file's not there or something's wrong with it, they just blow up completely. And sometimes that's absolutely fine, right? Sometimes you want to explode. But a lot of the time, you want to do something with that information. Maybe, file could be in two places. Maybe we want to check both of them. You've robbed the caller of the ability to do this unless you have a try-catch. The overall stack that ends up happening looks like this, right? So we have a problem, and then we call a helper function to do a subproblem, subproblem, subproblem. Something goes wrong, and then down we go and explode, and we lose the entire call stack. The other way of doing this, much louder. The other way of doing this is like this, right? So this is the try-catch version, where we call, something goes wrong, down we go, we rescue it, we blow up that call stack, and then build up a new one. Right? So it has this sort of pyramidal shape. I like to think of this as jumping off of a cliff, because we have something that looks kind of like this, right? And you either get rescued, you fall into the nice water, or maybe you don't, and we blow up the entire call stack again. Again, maybe this is something that you want, maybe this isn't, but it really depends on what the original caller was. So the call site doesn't know about the context that it's in, or at least it shouldn't. So as a controlled descent, we have exceptional, and that's the logo. So let's take a step back and talk about the overall philosophy of this library. Elixir is a great language, obviously. It has a large focus on developer experience, which is why everybody here is so passionate about it, right? What we've been hearing almost every talk is that we love Elixir. Why do we love Elixir? Because it's really focused on your quality of life, right? So any library that we build should really lean into that. We want to focus on our business logic, not on error handling, right? We want to stay on the happy path and either automate the error handling or leave that for later. We have this saying, let your children die. I'd like to update this with, let your bad children die. If 90% of your calls have some error, and you're going to raise, you're going to blow up that worker, and then the supervisor is going to restart it, you end up with a lot of thrash in your system, and that's not good, right? So yes, it's very lightweight, but it's also a question of what percentage of your calls are failing, how far through some function or some operation do you get before this happens? Is this happening during a database write, and then you're rolling back in a transaction? That's pretty heavyweight. You might want to actually recover from that. We like readability and visual flow. This is why pipes are so popular. And it's also really good for maintainability. When somebody's reading a pull request, they should be able to read like, okay, it does this, 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 and this. Great, easy. As opposed to doing some, especially with arrays, because you've lost control flow, it's going to get caught somewhere else, maybe, and you're not sure, and you have to do all this digging around. with the with style in the threading blocks, you end up with the problem of having to keep going back and forth and back and forth and back and forth, and then you might have a subversion of that, so you have now a nested with. Can become very frustrating for a reviewer. Any library rewrite should be compatible with the rest of the ecosystem, right? It shouldn't do something completely different. I know this is ironic, the author of Witchcraft saying this. I swear, Witchcraft does actually use underneath all the regular stuff, even though it feels very different. But things should work with the rest of the ecosystem. And then we should maximize context. This is, I think, the big thread in my career is about context is the most important thing in your code, right? We don't just write code for the machine. Yeah, it's a communication between us and a computer, but it's really between humans and between autonomous pieces of code. So the more context you have, the easier it is to do development, the more context you get back in a production log. If you just see a bunch of runtime errors and you don't know why it happened, it's much harder to resolve. I want to maintain control at all times of my code. I don't want it to automatically call up a stack that I don't have control over. I want to be able to pause it at any point, because being explicit is better than being implicit. So let's do some optimistic flow, ideally, because I don't want to think. I want all of this stuff to be automated, but even though it's automated, I want to maintain control, and I want it to be readable. So the one last piece that we need before we dive into the code is exceptions, which are built into Elixir. So there are these structs called exception structs. They have a special key called an exception, and they're just plain regular maps, right? Just like all other structs, just a special subtype of a struct. They can be inspected, worked with, logged, pull things out of them, recontextualized, turned into a regular struct, etc. And there's no magic, right? It's a struct, it's a map. It's one of the basic data types in the language. So instead of it being this threading model or railroad programming, and it's on a cliff, it's almost like zooming or a pyramid again. So if you think of this as side and top view, we make a call, we make another call, we make another call, and another call, and we have to follow these arrows because obviously we're making function calls, and then the opposite direction is always these arrows back. Right? Nothing else, no magic, nothing special. Right? We return values back from our functions. And if we want to raise, we still can. We can still jump off one of these ledges. So we get, in a lot of ways, this with style, because we can still pattern match, we can still use functions to pull values out. But ideally, we don't even need things wrapped in a tuple, because we can say, oh, this is an exception struct, and detect that, and just keep it flowing. Or just have a regular value and keep on going. We have what I'd like to call, using this metaphor, it's a controlled cliff jump, right? You're coming back, you're unwinding the stack manually, and if you need to raise, you still have this struct that you can call raise on, which is your choice to live dangerously. And you still have easy pattern matching, right? We're not depending on positional values. Wrapped in a tuple, it's a map. Maps are flexible. If instead of having to worry about is this the third element, the second element, where is this? You just grab it by a key. It's a key value. Exception as a module is built in. This is in the standard lib. Carry on more information, recontextualize. Talked about that a little bit before. And plug status, which is really great if you're in a plug application or Phoenix, and you add to your exception plug status as a key and then give it a number. When you raise it, it will return back that status code. So if it's a 404, 422, whatever. Some ancient functional wisdom is ask your parents. Again, if you're in this small subproblem in a helper function, and you're not sure if this is an error that needs to be raised or if it's something that we can handle, just ask the caller, send it back up the stack. They have more information than you do. So, again, flexible, familiar pipe-ish style, and we have the option of just in the operators defining how we want error handling to happen. So in this case, and we'll talk about this operator more in a moment, we have something that might be an error, might be a value, this triple arrow function operator into a function, and that will raise automatically if it's an exception, otherwise we'll pipe as normal. Which also removes the need for having a separate bang function for something that's dangerous and might automatically raise. So what does an exception look like? Here's one example. So you can document it. You get all kinds of nice stuff in your xdoc. This one's long, so that second one is just a continuation of the same file. And you have def exception, just like how you have def struct. Here's some keys in addition to the ones that it gives you automatically. This is a constructor .new, so it would be myapp.currency.rateNotFoundError.new. So you can even pipe values in to create one of these very easily. And we have a human readable message in here, in addition to having those same keys in the data structure, right, in the map. So when you get this in a log, it will actually read out for you, unable to find rate for Canadian in FivX, as an example. If you write a bunch of these and document the fact that you have, these are the ways that this thing could fail, in your directory, you have a few of those, right? So by convention, _error.ex. And now I have an understanding of, just at a glance, these are the possible errors in my application, right? And you want to push these, there's a balance, right? You want to push these as far down into your application as possible, right? You don't want just a top-level errors directory. So that you know that, in this case, rally chain can fail with an access denied error. And then above it, we can fail with a no address error, access denied, or rate not found. It's really nice for external services because you start to document all the ways that this external API may fail on you. And yeah, they get their own section in your docs as well. It's, you've probably seen it before, right? Pages, modules, exceptions. So you can just look them up right there, and they're just in one nice separate place. So let's look at the actual utility functions and operators. So this is for doing data flow in the let's not worry about the exception now, we'll handle it later way. We have a squiggly arrow, which works the exact same way as a regular pipe, except if it comes across an exception struct, it doesn't pipe that into the function, it just falls through. Which is really nice for chaining, right? You can do a whole bunch of these in a row. You can mix and match them with pipes as well, if regular pipes if you want to. This does not automatically rescue from a bang function. There's a way of doing that. We'll talk about that later. Some people find that surprising because I thought this is just going to propagate my exception structs. If you have a function with a bang on it, that doesn't give you back a struct. That just raises automatically. So it looks like this. So this one is business as usual because we have a regular value. These behave as a regular pipe. Right? So we're going to add 1, subtract 10, and then break that out into binary digits. Same thing again, but if we try to pass in a exception, we can skip all of that and fall through and just return the struct as is. And same thing happens If we get one of these partway through, same thing, we just drop through. And there it is. Types are great. Lots of people, they're getting more popular. A lot of people would be interested in having them in Elixir. A lot of people are using Dialyzer to get types as well. And so we can leverage that in our type specs here, because if we know that there are certain errors that could happen ahead of time, or exceptions, and they're just structs, then we have a type for them. If you don't have the type for it, you can still check, is this thing that I'm dealing with an exception or regular value with the built-in function exception.exception. So as an example, here we have foobar and baz that in this case, all of these will automatically return an exception. But imagine that they're integer or whichever exception struct they are there. And then we can aggregate them together and say that this composition of them on cux is all of these or an integer. Right? So we can delay this process till some point down the line, and it just affects, sums the variant together. Actually handling them, I mean, it's really crazy stuff here. We use a case for the success and the failure case, or the exceptional case here. And if we have several of them, and we want to recontextualize something, we can do that by looking at the enclosing environment and adding values into our maps, into our structs. So there we have one with input, talking about how we got here. Here's another one, we don't care about the modulus and the value. We can just provide, which value we were in, etc. You can imagine, lots of different ways of doing this. So what does this all get us? We don't need to wrap things in tuples anymore, right? That's just boilerplate. You don't have to do any value threading. That's handled for you by an operator. We can just pipe stuff through. We get automatic exception propagation. So you don't have to do anything by hand at all. And you can delay error handling until you want it. But we can still raise if we want to and get a lot of context in the explosion. There's two broad styles for this. One of them is a little bit, reads nicer than the other, but they both work. So one is with a closure, like so. You have a squiggly arrow into a function, and then you're saying everything inside there is safe, so I'm not going to worry about it. Only if I have a regular value will we continue inside. And the other is with just a regular sequence that we're going to check at every step along the way with a squiggly arrow. The second one is much more popular, as you can imagine, because you can just focus on just, it feels like a regular pipe. You can trade out the vertical bar for a tilde. There is an option to import or to override the regular pipe function with this behavior. I don't recommend it. A lot of people have asked for it, so I added it, but they have a different meaning, right? One of them is saying, I'm going to propagate structs through, and the other one says, I just handle all values the same. You can kind of do both at the same time if you break out your anonymous function here into a handler for this list, and then you can just squiggly pipe a bunch of these through, right? So that's just this one here moving up there. So what do we do with dangerous functions, right? Like file.read bang. Well, we have a bit of a hack, not a bit of a hack, we have really a hack to wrap these dangerous functions in safe. It creates an anonymous function with the same arity as the wrapped function. We have some pun-driven development, which is the right way to do things. So instead of raising, we have this lower function. which is just a synonym for safe. So you can lower, file.read bang. And yeah, really all this does is wraps it in a try rescue and then make sure that your resulting anonymous function has the right arity. That's it. So once we've detoothed some of these functions, what does that look like? So this is the regular enum.fetch, something that's way out of range. And then that blows up with an enum.out-of-bounds error. Here's us making it safe. And now when we call that same thing again, with the same values, we get this, which is just, again, a regular exception struct, a plain value. And then calling it with a regular value, it's just like a regular function call. So that's all great. Keeping things safe is fine and whatnot. But what we really want to talk about are explosions, right? Yeah. So what's the opposite of safe? Right? Sometimes you want to fail instantly in a chainable way and say, if anything along here is unsafe, I'm telling you that any of these exceptions should explode. We have a named version called raise or continue, which is similar to exception or continue, which is the squiggly arrows named version. And one called ensure. So ensure does nothing to regular values, just returns them. It's like an identity function. An exception struct will get raised, like so. This has a semantic meaning. In fact, so does the triple arrow function, right? We're saying that I guarantee to the programmer or to the program or to other programmers that this thing works now, it's safe, and if not, we need to get out of here. So let's look at the operator version. So this feels like a pipe, right? Regular values piped in, turns into a regular value. And if we do the same thing with an exception struct, we raise it, which is different from the squiggly arrow, right, which would return the actual regular value. So raise instead of propagating. Nice thing with having all of these similar looking operators is we can mix and match them. They all work together, and they just have a different meaning. So even as you're reading down, you're saying, okay, well, I'm piping through on the happy path, it's going to do these things. Oh, one of these is shifted over a bit further than the rest. That one's a little bit dangerous. Now I know about that. So here's a regular pipe. This one that will propagate through and just drop down. This one here will raise. So we're saying that everything below this is going to be safe. And then, or just regular value, no exception struct. And then this one will propagate as well. There's one more piece, which is def bang, which generates both your war and peace functions. Please, when you're writing a library, don't only give me a version that raises, right? I don't want to have to wrap things in safe or in lower, right? Give me a version that returns an exception struct and one that can raise, right? Pretty simple. And all you have to do now is add an exclamation point to def, and it'll just generate both of them for you. The other advantage of this is this becomes very, very easy to test, right? Because your raising version and your non-raising version behave the same except for how they handle errors. So in your tests, you can have a totally pure returned value to look at without having to do anything else, without having to assert something about how it raises or wrap it in a try catch or a try rescue, none of that. Shockingly, it looks like this, which generates a regular foo function and foo bang, right? pretty straightforward. Lastly, sure that by now we all wish that we just lived in this exceptional world, but we don't. So we need to play well with others. So we can recover a classic tagged tuple, error or OK, with a function called OK. This is somewhat limited because we're going to lose a lot of context coming out of the exception. But looks like this. Right, so it turns a regular value into an OK and a value, and turns an exception into error, and then the message that's part of the exception. So message is one of the keys that comes standard. Going the opposite direction, right, we can normalize exceptions, or tuples into exceptions. Ideally, you do this by hand because we only have so much context, as library writers about your specific use case. But if you have an error tuple, we can unwrap the OKs just normally. An error tuple becomes an Erlang error, and everything else just passes straight through. So if you try to normalize 42, we get back just 42. Normalize an error, we get back an Erlang error. And if we try to normalize exception struct, it's just a regular value. There's nothing special happening here. We just get that struct back again. So in summary, we're able to go both directions on lots of different things, all for your error handling. So we can make things normalized or OK, go both directions on that one. We can propagate exception structs or raise them as we're going along. And we have safe, which turns something that raises into something that doesn't, and ensure that turns a exception struct into a raise. I've had a lot of people say, OK, yeah, this is a monad, right? It's coming from Brooke. She writes all this crazy functional stuff. This feels kind of like a maybe or an optional, depending on which language you're coming from. Let's just crush those dreams right now. No, this is not a monadic error handling library. If you want one of those, it exists. It's called Algae, and you can use either. I've had a few people say, like, hey, could I write a results type, like what I'm expect from some other, or what I'm used to for some other languages? Yeah, absolutely, please do. But while I have the stage, monad is a very specific thing, right? It's not just about having do notation or piping or propagating errors. You need to have all of these different instances first. It needs to match those graphs. I'm sure that if you did enough diagram chasing, you could get something that kind of looked like it, but at that point, everything's a monad. It's not even in the spirit of it. And I mean, I've tried, and I'm pretty sure it's not even possible with all the subtyping and isomorphism in the world. Just, it's not. So, on that note, thank you for listening. You can read the document, see the package on hex.pm. Package is exceptional. I'm XP'd basically everywhere on the internet, and thank you.
Thank you, Brooklyn. Do we have any questions?
Great talk, by the way.
Thanks.
I have a question in regards to, I like that a struct is being returned an exception struct that you can still pattern match on. You can still continue to do that. I'm curious on your thoughts on why the Erlang ecosystem and inherently Elixir chose this tuple path, and kind of how that evolved to continue what it is today.
Yeah, absolutely. So why are we still using tuples? So Erlang was designed to solve a very specific problem, right? High performance telecom switches in 1986 with extremely limited machine resources, right? Tuples are much lighter weight than a map. Honestly, I think that's the main reason. When Elixir first came about, they were really pushing towards this struct direction, and I feel like in the last two years-ish, things have really been pushing back towards tuples, and especially the width style. My best guess is raising is dangerous, and nobody had really looked at doing this in a more pure way, A. And B, we still have to talk to Erlang libraries all the time. So we need to have some interoperability, and just making that the base default is one way of doing it. With something like this, you can kind of have both. Obviously, this is there's a matter of taste here too, right? This is a way that I like to do things. A lot of the teams that I've worked on like this, despite the other libraries I've written being, much larger and harder, this is the one that I get fan mail about, right? So I think that there's something here. It would be nice to see some of these patterns end up in more other libraries and more people using it. But I think that's really what it comes down to, is adoption and interoperability.
Awesome. Thank you.
Hey, how do you handle process exits? So if I spawn a process, like a task in one of these things, and it dies, the exits are sort of a different mechanism than a standard exception raise, and what's the story there?
Yeah, so this library doesn't look at it at all. So yeah,
Great.
This is really at the function level, nothing about the process level. Yeah.
Okay, great.
Any other questions?
Actually, I'm kind of curious. I'll just poll the room. Has anybody used exceptional? All right, a couple hands. Awesome, great.
I think I had a question.
Yeah.
So now you can get the stack trace from. I know that changed recently, right?
Yeah.
Is there exceptional give you any context around the stack trace or anything like that?
Yeah, so because you're returning just a regular struct, you don't get a stack trace because you haven't raised. Once you do raise, you're in that same flow, that regular way of doing things. You're unwinding the stack manually. So at each step, you can absolutely inspect it. We don't need a trace because you have control every step of the way, just like with a regular value. So yeah, I guess that's the other way of saying it. You don't even need a stack trace.
Cool. That's it. Everybody, round of applause for Brooklyn.